Hello and welcome to the Azure Machine Learning course. In this lecture, we will see why machine learning is the future. And before we do that, let's just try to understand some measurement of data. Now, we know that 1 terabyte is equal to 1000 gigabytes. Let me go to the next step. 1 petabyte is equal to 1000 terabytes. And going even further, 1 exabyte is equal to 1000 petabytes. And in case you wonder, why am I telling you this? Well, there was a study done by IDC and Seagate way back in November 2018. It was called Digitization of the World. And as per that study, it predicted that we would generate more than 175 zettabyte of data by 2025. Now, 1 zettabyte is equal to 1 billion terabyte, and majority of this data is going to be unstructured. So can you imagine how huge that data will be? It is impossible to make sense of this data using traditional means of hardware and software. And that is where the machine learning can help in understanding the data, and it can also help us in making intelligent business decisions. One more important statistics is that 90% of the entire data in the world has been produced in the last few years alone. And it has been done by various industries such as biotech, banking and finance, manufacturing, telecom, e-commerce, and of course the social media, which is the biggest contributor of this. So it's not a surprise when some of the leaders of the industry are calling big data and the machine learning which powers it as the next big thing. Harvard Business Review called data scientist as the sexiest job of the 21st century. Also, Microsoft CEO Satya Nadella called out machine learning as a key development in his memo to Microsoft in July 2017. And they say that data is the new oil because it is going to drive critical business decisions. And it can also help companies save some cost as well as find out new business ventures and avenues. Let me also tell you an interesting story of machine learning during BR exit. During BR exit, the pound sterling was down by 11% 2 days after the vote. Stock markets crashed, and this left millions of traders all over the world scrambling to find some safer investment positions. But there was one company called Omega Point, and its customer saw very little change in the value of their investments after the BR exit vote. And the root of the investing success during this time was a data-driven strategy based on machine learning models. They took into account more than 50 economic indicators, including some of the company-specific reports and broader macroeconomic data. Then even the LinkedIn used it very cleverly. The people you may know ads that we see from LinkedIn is another great example of machine learning. It achieved a click-through rate of 30% higher when it was launched. They generated millions of new page views, and thanks to this one feature, LinkedIn growth was significantly upward. Then we have self-driving car, product recommendations, Uber face identification of their drivers before they accept a ride, Google Home, Netflix movie recommendation, as well as Siri in Apple iPhones, which are some very familiar examples of how machine learning is being used in our day-to-day products. Machine learning can be of huge benefit. It can be used to pick the best results, and that's why we can reach decision faster. We can develop insights that are beyond human capabilities based on the patterns derived from the big data. And with all of that, we can act at the right time and take advantage of sales opportunities, and then converting them into closed deals. Alright? Then, the next question is, why should we learn Azure ML among so many other products and technologies that are available? Well, please allow me to explain that using a very fascinating case study of Hershey's. Hershey's leveraged the power of machine learning without hiring a data scientist. Hershey's products are sold in over 60 countries worldwide. And at that time, they had a revenue of $7.4 billion. And one of the best-selling products of Hershey's is Twizzlers. I love them. Each 1% change in sizing for Twizzlers actually results in a savings of $500,000. And why do you think Hershey's could achieve this without hiring a data scientist? Well, the answer lies in Azure machine learning capabilities. It has a very good drag-and-drop interface, and within that, almost no programming is required if you use Designer interface. You can follow a workflow and build a great ML model just by using Designer or the Classics Studio. Then Microsoft has made available a large variety of algorithms as modules. All you need to do is simply drag and drop them on your canvas to build your model. And because many of these models do not require coding, you can literally go from experiment to production API in matter of minutes for simple experiments. But that's not all. It also supports R and Python. And this is particularly a good news for those who know R and Python or have built some models using those languages. Azure ML supports R and Python to bring in your existing code and existing models. Then another great feature of Azure ML is it provides a complete flexibility of data storage and supports variety of data storage options. Microsoft also has a large number of pre-built APIs available as a service. Then some of the large companies such as Tata Motors, the makers of Land Rover, Uber, Rolls-Royce aircraft engines, Xbox, and many more are already using Azure Machine Learning. CIO.com once published an article, and it says that Microsoft Azure Machine Learning is a one-stop shop for cloud-based machine learning, and it can be a real game changer. And with all of this cover, I'm sure you are now ready to take this step of learning Azure ML, and I'm also equally excited. So in the next lecture of What is Machine Learning, we will understand the definition of machine learning, how the machines learn, how machine learning is different than the traditional rule-based systems, as well as supervised, unsupervised, and reinforcement learning. So let's move to the next lecture, and thank you so much for joining me here. Hello and welcome to the Azure Machine Learning course. In this lecture, let's try to understand the big question of what is machine learning. Then we will see some examples of machine learning as well as supervised, unsupervised, and reinforcement learning. So what is machine learning? So first, let's look at the academic and simple definition of machine learning. Now, as per Arthur Samuel, machine learning is the subfield of computer science that gives computers the ability to learn without being explicitly programmed. Now, what does that mean? And how does the computer learn? Well, it is very similar to how we humans learn. Human behavior is usually dependent on the events in the past. Similarly, machine learning algorithms depend heavily on the extraction of knowledge from the past data. Then we build a set of algorithms based on the patterns found in the data. I'm sure it sounds very theoretical, so let's try to understand that using how a kid learns. And this analogy is just for understanding purpose. Alright? So now, if you show a kid a picture of an apple or hand it over an apple and ask what is that, he or she won't be able to answer it, simply because it does not know about it. But when we tell her that this is an apple and this is an orange multiple times, they are able to identify it correctly after some time. So what is happening here? Well, the brain has identified various data points associated with the fruit, such as its color, its shape and size, and so on. And it can also identify the differences in these among various fruits. But it does not know what it is called. So when we label it as an apple or an orange, the brain assigns the label as the result of those data points. Alright? And very similar to that, when we feed lot of data to the machine and tell it what it is, the machine learning algorithm then assigns the result to the historic data and can also predict the future values of labels. Great. And let's now see why machine learning is important in today's world. Well, traditional IT systems depend heavily on the data match or mismatch with the set of direct rules, which then triggers some action. For example, in one of the projects I worked on, there was a rule to audit a refund more than a particular amount. And what that meant was every high-value tax refund will get audited. Now, fraudsters are very smart, and they always test the systems to identify such rule-based thresholds from outside the systems. But a new data analysis-driven system that looked at various aspects of a transaction and related entities can predict the outcome or likelihood of the outcome based on historic events and not simply some direct match or mismatch of rules. I hope I'm making sense here. Now, depending upon what and how we achieve the end result, machine learning can be categorized into 3 categories. And those are supervised, unsupervised, and reinforcement learning. So let's take a look at the supervised learning with some basic example. So when you were a kid, solutions were provided to you. We all were guided by our parents and guardians. And those solutions and decisions were based on their past experiences. And you learned as you grew. That is nothing but supervised learning. But when you start taking your own decision without any such result or outcome-based intelligence, it becomes an unsupervised learning example. Let's take a look at it in a more technical language. So in case of supervised learning, the data is labeled, which means both the dependent and independent variables are provided. The historic data helps us to find out a relationship between this x and y in the form of a function of x. And then we can use this function to predict the value of y if we know the x. And some of the examples are regression analysis, where we try to find out a real and continuous value of y as an example of supervised learning. Then another one could be that of classification, such as yes or no, predicting who likes which color, and so on. Now, in this data set, we have some data that tells us whether the loan of a customer has been approved or not. Now, such historic data helps us to identify the pattern to predict whether the loan of another customer will be approved or not. So we basically take this historic data and build our model to predict future values of Y. I hope it makes it clear at a basic level. We will see various types of models, and then we will also build them as we go along. Then in case of supervised learning, only X variables are known. So the goal for unsupervised learning is to find out if there is any structure in the data, or it follows any particular pattern or not. And here we don't have correct answers, and there is no teacher also. So what we mean by that is algorithms go on their own to discover the structure in the data. So an example of that could be grouping of customers based on their behavior. And we are talking about financial behavior. So something like high spenders and their spending patterns. Or another example could be a recommendation model for the products, which would be liked by a set of customers. All right? Great. And that brings us to the last topic in this lecture of reinforcement learning. So let me go back to the example of a kid learning in a supervised model and an adult taking some decision in an unsupervised way. But how do we know if those decisions taken in an unsupervised manner are going to give us the desired result? And that is where the reinforcement learning helps us by rewarding the good decisions and penalizing the bad ones. It's something like you should pay your bills on time. The reward is a good credit history. So similarly, the unsupervised learning may group a set of customers correctly using their spending patterns. And now your marketing department wants to show them a set of advertisements. Now, without any past data, how do we maximize the reward or the gain? Which in this case is click-through rate, which means if the customer clicks on that ad, it's a good ad, or it's a relevant ad for that customer or for that group of customers. And this is achieved by reinforcement learning. And we would look at supervised and unsupervised learning as we deal with some real examples. For now, that concludes this lecture of what is machine learning. So here we covered some basic concepts of what is machine learning, some great examples of how it is being used in the real world, and finally different types of machine learning. In the next class, we would look at this mysterious element called data, which seems to have all the answers and a guiding star for all the machine learning algorithms. So go get yourself a cup of coffee and I will see you in the next class. Have a great time.